So the term system bus is a term where you're referring to all three of the other buses together. Okay, so you've got three buses, you've got data bus, address bus, and control bus that you'll start to learn what the differences are between those and how that they're used by the processor. But the system bus as a term is just a term for all three buses together. They're known as the system bus. Okay, so you've got a data bus. The data bus transports data, funnily enough, and instructions between components on the motherboard. And it's bi-directional, so data bus can send data in both ways to and from the processor. So the data bus, all these buses, just in case I haven't mentioned it, are just basically wires. They're like certain tracks on a circuit that can send electrical current data down. Okay, so data bus, those ones and zeros that travel down that are data, and it can go in both directions. You've got the address bus, which is single directional, which sends address signals from the CPU to memory. These address signals contain specific addresses, so when it wants an instruction, it will send the address of that instruction or data, send the address of the data to memory, but it only goes one way. It goes from the CPU out. You've then got the control bus. This is bi-directional, so it sends control signals between components. So examples of control signals include things like interrupt requests, which we've kind of previously mentioned in some other videos, clock timings, which we've not actually mentioned the clock yet, but it will be mentioned in lots of videos. And the control bus is bi-directional. Now, that's them as a concept. If we look at a three-box model to try and help us understand how these work. So you've got in your three-box model, you've got your CPU, main memory, which is your ROM and your RAM, and your I/O controllers. Your I/O controller is any input-output device. Okay, so your secondary storage, your main memory, your big hard drive will be I/O. Your keyboard, mouse, monitors, all I/O, printers, etc. So what happens is your CPU might be sending data between these components. You see, it's bi-directional. Okay, but it might also be receiving data from these. So you think a keyboard might send letters to the CPU, okay, to process. So you see that's really important, that that's bi-directional. The address bus, however, if the CPU wants to send an address to main memory or the I/O controller or your hard drive, etc., if it sends an address, these devices will respond with the data from that address. Okay, but you can see how that's only one directional. So if you imagine, if the main memory receives an address, the stuff that's in that address won't go back via the address bus, it'll go via the data bus because it's data. Whether it's an instruction or data, it goes on the data bus. So you can see why that's one directional. And finally, you've got the bi-directional control bus. So that's for all the control signals. So for the CPU to tell devices what it wants it to do. You can see they might send control signals. So an example of a control signal, a simple one, would be if I send an address to main memory, I also need to send a control signal. Because if the main memory just receives an address on its own, it doesn't know what to do with it. Whereas if I send a control signal saying read or write, if it receives an address and a write down the control bus, it knows, oh, I'm writing to that address, whatever's in the data bus. If it's read, then I need to get what's in that address and send it down the data bus. Okay, alternatively, for them to come in the other way, you might have to interrupt the CPU doing what it's currently doing, which is a signal down the control bus to the CPU. So you can see why, again, this is bi-directional. Hopefully the three-box model helps you understand the buses a little bit better.